Okay, so you guys requested in class today to get a YouTube video of how to find the excess reactant. So I'm looking at the worksheet that I assigned today in class, and I'm looking at number 12. This is not one of the problems that I assigned. This is just something I'm using as an example. So on the worksheet, it says what mass of SO3 is produced from the reaction between 12.7 grams of SO2 and 3.45 grams of O2. That's the first part of the question, and then I added to this worksheet that you guys need to find the mass of the excess reactant remaining. So the first step when we do all of these problems is to identify what the limiting reactant is first. So that's what we're going to do first, is identify the limiting reactant. So I think everyone's pretty solid on this, but just in case, here comes the explanation. So finding the limiting. Okay, so what we're going to do is we're going to do two stoichiometry problems, starting with either of our reactants solving for the same product. So the SO2, we start with 12.70 grams of SO2. I'm going to have to turn that into moles first. Now I got my grams into moles. Now I need to relate my reactant to product using the mole ratio. So then for every 2 moles of SO2 I have in my reactants, I have 2 moles of SO3 produced. And now I'm going to get into grams because the problem was asking how many grams of SO3 we can produce. So now I'm going to go from moles of SO3 into grams by multiplying by its molar mass. Okay, so once I do that, I get 15.87 grams of SO3. So that's how much 12.7 grams of SO2 can make of SO3. On to the next problem, or the next reactant. Now we look at the O2. We have 3.45 grams of O2 to start with, and we're going to turn that into moles. Okay, so this step got us from grams into moles. Now we're going to relate the mole ratio between reactants and products. So for every 1 mole of O2 we have in our reactants, we get 2 moles of product. And then lastly, turn that product of SO3 into grams. And when we do that out, we get 17.26 grams of SO3. So looking at these two problems then, here's our first reactant, here's our second reactant. We have a different amount of product that can be made. So by definition, the limiting reactant is what limits how much product can be made. So then this is the smaller amount of product. So that means SO2 is our limiting reactant. So this is how much of our SO3 product we can make. And from this information, we can also know that SO2 is limiting. And we know this because it made less of the product. Okay, so now we've identified our limiting reactant, and we've identified how much of our product we can make. The next question is what mass of the excess reactant remains. So in this case now, we know that the excess reactant must be the O2, because the SO2 is limiting. So to figure out how much of the O2 is left over, what we have to start with is the given amount of the limiting reactant. So finding excess. So we always start out with a given amount of the limiting reactant. So in this case, our problem of the limiting reactant, which was we identified as SO2, we have 12.7 grams of it. So 12.7 grams of SO2. And we have to figure out, okay, if we're making this much product, how much of the O2 did we use to make the product? So the first question is, okay, we know we're going to have a little bit of O2 left over. How much did we use to react with the SO2 to make the product? So let's do that. So the first thing we're going to do then is turn this into moles again. And now, instead of using the ratio between the reactant and the product, we're going to use the ratio between the reactants in order to figure out how much of the O2 is used when we used up all of the SO2. So that is a 1:2 ratio. So for every 1 mole of O2 used, we use 2 moles of SO2. And we're looking for this in grams, so we're going to go one more step and multiply this by the molar mass to get into grams of O2. And so doing all that math out, we get 3.18 grams of O2. And guys, this is the big takeaway. What we just calculated here is how much O2 we used to react with our limiting reactant to make our product. That's what this number signifies. So this is how much was used. I cannot stress that enough. People mess that up every single year, okay? So now we know how much we used. Now we can figure out what's left by taking what we started with. In the problem, it says we had 3.45 grams of O2 to start. So 3.45 grams O2 starting with. And we're going to subtract what we used, 3.18 grams of O2 used. And that's going to give us what's left over. So now we have 0.27 grams of O2 left. Okay, so now you know how to identify a limiting reactant, how to figure out how much of a product will be made, and how much excess is left over after reaction is done. If you have any more questions, don't forget I'm always here after school and during lunch.